Okay, we're in section 22 of the notes now. We're kind of plowing our way forward. Again, I know some of these sections have been difficult, particularly things with the factoring of symmetric expressions. But for the most part, I mean, it's kind of introduction of pattern recognition. But the bottom line is you don't know what you can enter until you move forward. All right, you want to move forward into these things. Now we hope it has some relationship to your past. That is, that this course goes forward, and the going forward relies upon your understanding of the past. Maybe not completely, but partially. All right, you can't understand everything about the past, but the further you go forward, the more likely you're going to understand the past better. All right. So again, my name is Ron Bannon. That's up here. If you do need to reach out to me, my email address is Bannon. That's B as in boy, ANNON.US. All right. This material that's being offered to the students, the PDF that you're seeing on the screen right here, is for the Prison Mathematics Project people. And, at some point I will publish it. It'll be out there. But right now it's only for the Prison Mathematics people. But you have access to the document in this little videos over here. It's just not in its entirety. All right. I do scroll through it, though. It's probably not the way you want to see it. But at some point I will be publishing the document. Okay. Let me just kind of go through it and see what this one's all about. And again, the bottom line is, he definitely introduces something. He talks about, the equations with roots and stuff, and what you have to do to get the other roots, and we'll go through that. But I get a very sparse section. If you look at it, that's it, and then he goes right to example. All right. So what I'm going to do, I'm going to go to the examples, but I'm going to go through it. I'm not going to talk through it the way Wells would do it. I'll do it the way I would do it if I were presenting this. And what they do is I'll point it out for you. They give this equation over here, and they want to know if this is a root of it. And you might think root's a very peculiar word, but it's not. It's really asking, is it a zero of the problem? Why is it a zero? It's almost like the x-axis of our problem is somehow like the root of the earth or something. So I write it down. And what I do is I parenthesize the variables, and this is typed up where I realize that. So I would put down 3. Whoops, sorry about that. I didn't mean to do that. I would put down 3. I would parenthesize, and they say minus 2/3 to the 4th power. And then there's an 8 minus 2/3 cubed. Then they got 13. And it's tedious, I realize that. Especially if arithmetic is proving to be difficult for you. Plus 9 minus 2/3 plus 2 is equal to 0. By the way, that's a question. I don't know if it's true. Let's take a look at it. So I like to start easy. I'm seeing, I don't know. I'm seeing a plus 2, right? Now, if I did the second term, which I think is easy, 3 goes into 9 3 times, and 3 times minus 2 is minus 6. I think the next one's pretty easy too, by the way. But again, you may disagree with that. And I'm seeing 4, because minus 2 squared is 4. And 4 times 13, let's take a look at that. What's 4 times 13? 4 times 13 is 40, and 4 times 3 is 12. 52, right? So I can say 52, and then there's 9, because 3 squared is 9. Let's do the next one. And again, you might say, no, it's too much. Right, that's plus, though. The next one would be minus. I'm going backwards, by the way. I'm just doing one at a time, going backwards. That's going to be, let's see, minus 2 cubed is, minus 8, and minus 8 times 8 is minus 64. Okay? And 3 cubed is 27. All right, let's keep going backwards. I'm going to do the next guy, and I'm looking at it, and again, when I'm looking at something, you may be looking at something different, but I'm kind of looking at this. Whoops, I didn't mean to do that. I'm looking at this 3 here, which is 3 to the 4th, and a 3 there. And that would really just be a 27 on the bottom. Okay, I'll put that down. Pretty simple. Doing it again. 27. And what do you get in the numerator? It would be minus 2 to the 4th power. What's a positive number? 2 times 2 is 4, 8, 16. All right, it's tedious stuff. I realize that. And again, I understand. I wonder if that's equal to 0. And if it is, I got a root. All right? So let's see if we can do it. And not that bad. I mean, minus 6 plus 2 is minus 4, right? And let's see, I'm going to do these two over here. And 16 minus 64, right? That's 48. And then I got plus 52 ninths. Well, you know what? I think 48 and 27 reduces, doesn't it? And by a factor of 3. So it's 16 ninths plus 52 ninths minus 4 equals 0. You know what? I think I made a mistake somewhere. Ooh, I see it. That's minus 48. Sorry about that. This is minus 16. I'm glad I made a mistake because I get a chance to correct it. And you should also be thankful for a chance to correct a mistake if you make it. So what's minus 16 plus 52? Let's see, 46, 36. I'll put this over here. And yeah, it's work. There's no doubt about it. 36 divided by 9 is 4. 4 minus 4 is 0. So now I'm convinced this is a root. All right, so someone says, would you do that? Let me just go through. I'm going to erase my chicken scratch work because I know it's true. I know it's a root. So I'm going to start to erase all that stuff I did up here. Any kind of room. So let me repeat what we just did. We just verified that this was true. Let me highlight it for you. We verified that this is true. So what do I know? I know if this is a root. I know a factor. And I'll write that down for you. And the reason I know it's a factor is if it's a root, there's a 0 in the problem. So I know this. I know it's going to be x plus 2/3 times something, I just don't know what yet, would equal 0. Let me repeat this. Why do I know that? Because if you plug in minus 2/3 here, this would make this 0. And I've already verified it's a 0. But I don't like the way that looks. So what I'm going to do is I'm going to multiply both sides of the equation by 3. Now what do you get? If you did that, I'm going to associate it like this. What do you get? 3x plus 2, unknown. I don't know what that factor is. And what's 0 times 3? 0. My trouble is, what's this? I don't know what that is. But the way I'm going to obtain it is I'm going to divide this by this to find this. Let's do that. 3x plus 2 is being divided into 3x4 plus 8x cubed plus 13x squared plus 9x plus 2. And what's wonderful about this division, if I do everything correct, I know it's a root, by the way, the remainder's got to be 0. Let's take a look at it. What times 3x would be 3x4? That would be x squared, wouldn't it? I'm sorry, x cubed. What do you get there? 3x4 plus 2x cubed. Let's subtract. What do you get? 6x cubed. Let's drop the places down. I like to drop everything down. Let's repeat. What times 3x would be 6x cubed? Well, I'm going to say that's plus 2x squared. What do you get? 6x cubed plus 4x squared. Subtract. What do you get? 9x squared plus 9x plus 2. Let's keep moving. What times 3x gives me 9x squared? That would be plus 3x. Let's go through the multiplication. 9x squared plus 6x. Subtract. What do you get? 3x plus 2. What times 3x matches 3x? Plus 1. I got it. And so what'd you get? I got the other factor. So let's write that down. So I know that this thing over here now factors. I'll write this down for you. And it factors into this. So I'm going to say that really fourth degree awful looking polynomial now factors into, let's write this down, and you could check this if you want, 3x plus 2 times x cubed plus 2x squared plus 3x plus 1 equals 0. Now, I want to go back over here and the bottom line, it just that it didn't ask me to factor it, but I'm glad I did this part because it's important you can get that. And here comes the other conundrum we have. Is this factorable? Right? And you could test it out. I'm not sure they're going to ask that, but you could do that. You could try to factor that. But there's a very short section, all right? Very short section. Basically what they're saying, if you know a root, you can kind of depress the equation to a simpler one. And what do I mean by that? I had a 4th degree polynomial, and I'm depressing this thing to a 3rd degree. And the further you can go down the chain, the easier they get. For example, you could take a cubic, you could depress it to a square. You could take a square, depress it to a linear. It's not a bad thing to be doing, right? We'll do more of that later, but right now it just does one thing. So here's the deal. There's exercise. What do you do in the exercise? They want you to verify things that are roots. I'm also doing the division for you because it's useful. The other thing I want to point out to you, when you do division, you get a 0 each time if it's a root. So someone says, I'm just going to do the division. You're right. A lot of people just do the division. My gut feeling, though, is you probably should practice that arithmetic first before you do the division. But once you do the arithmetic, you verify it's 0, the division should be really simple. Now this one over here, I want to point out, if that's a root, x plus 5/2 would be a factor. It's the question, what goes over here? Well, I got to be honest with you, this is a cube. This would be quadratic, which would be much easier to deal with. Now the deal about this one over here, I would multiply both sides by 2, and I'd get 2x plus 5. That's easier for me to deal with, by the way. It's really the same problem, all right? But easier for me to deal with. When I go through that, though, I want to point out that's what I'm doing over here. So don't be confused by that. Each of these problems we do for you, and I hope there's enough work there for you can master that on your own, all right? Enough work for you to master this on your own. Enough work, right? What do we get to at the very end of it? Again, I want to point this out to you. What are you getting to at the end? You're getting to the SAGE stuff. What's SAGE? It's a computer algebra system, or a CAS. It's free. What I mean by that, it's open source software. It's widely used around the world. I think most mathematics, place where there's math being taught or used, that they would have access to SAGE. That's the website. You go there, you can download the software if you like, or you can use the interactive web app application. Our objective, though, is to get you to try out some code over here. Right? I like code. Code makes things easier for me. But the bottom line is, you may wonder how people write code, right? How the machine is doing that. And someone programmed it. They would need to know the algebra to do that, though. And you need the algebra to know why you would do that, all right? Why you would need to do that, all right? So you're really learning algebra. You're not learning coding. But it can't hurt to get your feet wet. I really mean that. Hang in there, though, and thank you for paying attention.